hard not to identify that.
Awesome. Okay, so as I said, this will be the training seminar for our new process for hazard reports, alerts, and recalls for Lower Mainland Biomedical Engineering. So Laura and I have put together a training package to complement the PowerPoint that we'll go through today. So the training package includes a PowerPoint document, and that's what we'll be going through. There's also a guideline document that Laura has created for supervisors or technologists that are acting as delegates on behalf of the supervisors, and it kind of spells out the need-to-know information for being involved with the process. Further to this, Laura's also created 4 different YouTube videos. So there's one on alert log navigation, alert log querying, creating risk management work orders, and then duplicating those work orders. And so all of this information and the location of where these documents are, we'll follow up with in an email after the presentation. There's also a standard operating procedure that describes the overall process. In terms of helpful resources, the actual SOP is a bit of a dense read, so if you have questions or if you're looking for guidance, I think the PowerPoint or the guideline document or the YouTube videos would be the best resources. And then also the engineering team and Laura is also around to help if you have any questions. So an overview for the presentation. I'm going to start by talking about the provincial alerts process that's in place, and then how that then flows into our lower mainland biomedical engineering alerts process. So the provincial process starts with ECRI. So I'm sure everyone on the line is familiar with ECRI or ECRI. They do lots of different stuff in the biomed realm. But one thing that they do is they do alerts. So basically, ECRI identifies, standardizes, and distributes alerts. And through this, they've monetized the whole process. So various customers or member hospitals will subscribe to the ECRI Alerts Tracker service. And through that, subscribing healthcare institutions will receive alerts directly from ECRI. And this has some benefits. So the process starts with the identification stage. So ECRI receives alerts directly from member hospitals or vendors. The vast majority of alerts that ECRI does distribute come from member hospitals. So within Lower Mainland Biomedical Engineering, we might receive a letter from the vendor indicating that there's an alert on a specific device. And then we might choose to forward that alert to ECRI. And what ECRI will do is they'll review that alert and then follow up with the vendor or the manufacturer and say, hey, we saw this, can you provide us more background? And so that's how ECRI finds out about the vast majority of alerts. But then in addition to that, they also monitor various regulatory agencies. So there's the FDA, Health Canada, MHRA, which is European Regulatory Authority. And so they're also actively looking for new alerts that have been distributed by various organizations. So once ECRI has identified an alert, they will standardize it. And so I'm just going to pull up an example here. So this here is an example alert that's come from ECRI for a Natus NeoBlue LED phototherapy system. And so one of the big advantages of subscribing to the ECRI alerts is they put it into the standardized template, which has kind of the key information that a healthcare institution or a biomedical engineering service or organization would be interested in. So just skimming through this alert, there will always be a priority attached to it, and I'll talk a bit more about that. There will be a very specific product identifier. So it will state the precise make and model of the affected device. The geographic regions that are affected will be included. Suggested distribution of who this alert should go to. And then there's always a summary problem and the actual action that's recommended by ECRI, and the manufacturer is included as well. Any reference documentation will have links to that at the end of the document. So every ECRI alerts will look very similar to this. And again, one of the advantages is we always know kind of what to expect within an ECRI alerts and the information that they'll contain. So jumping back here to the presentation, so there's 3 different alert types that ECRI distributes. So action items, hazard reports, and special reports. Action items include anything such as recalls, field actions, or any other regulatory action that's required by a regulatory body. So that's the vast majority of alerts that we accept into our Lower Mainland biomedical engineering process. Hazard reports involve any sort of safety issues that have stemmed from identification, let's say, at a local site, or ECRI's been receiving reports of certain incidents, but often hazard reports aren't coming from any sort of regulatory action that, let's say, Health Canada has required a vendor to perform or a manufacturer to perform. And then lastly, special reports, they're quite rare, and they can be related to issues related to actually managing a recall or alert. They're sort of similar to literature reviews where ECRI might provide some general guidance on a specific type of hazard that might be within our healthcare institutions. So I would say the action items are the alert types to focus on, and those are the ones that you would see the most. As I mentioned, there's always a priority that's assigned by ECRI to the alerts, and the priority is assigned based off of the probability of harm to the patient or operator in relation to that alert. So there's 3 priorities: critical, high, or normal, and again, that's related back to the probability. So something that has a higher probability of patient or operator harm would receive a critical priority, and then lower probability would be a normal priority. In most cases, we will look at ECRI's priority that they have attached to alert, and we will accept that priority. But sometimes we might look at it and think, okay, well, ECRI has assessed the probability of this alert. The hazard described within this alert causing harm is low, but we feel like it's a bit higher, so we'll put a higher priority on it. So for the distribution of the alerts, so as ECRI identifies, standardizes, and publishes these alerts, they're sending them out all the time. So there's RSS feeds that you can subscribe to, where every single time ECRI publishes an alert, you will receive a notification. So today, ECRI will publish, I'm not sure, let's say 10 alerts, and those will come through the RSS feed. In addition to the RSS feeds, there's also a weekly alert compilation list. And so that weekly alert list is distributed at midnight on Thursday, so at the end of Thursday, beginning of Friday. And that weekly compilation list includes all of the alerts that were distributed from the previous week. And so it's that weekly alert compilation list that drives our provincial BC alerts process. So these next 2 slides have a bit more background information about alert priority and the various alert types. I'm not going to go into them in detail today, but if you're interested, we have included those for further reading. So now moving into the provincial alerts process. So there's a provincial alerts process in place that's led by PHSA Supply Chain. And this process involves alerts related to equipment and consumables that don't just involve stuff that biomed would get involved with. So this pertains to all sorts of medical equipment or equipment in general that's within our hospitals. So this process begins with that weekly ECRI alert list that's received by a BC biomedical engineering representative. So those representatives, we have 2 of them, Laura Young from the Lower Mainland, who all of you know, and then Chris Vandermark from Ontario Health Authority. And so these two individuals are our provincial representatives because they have very broad knowledge of the devices that we service because of their involvement with the database and risk management issues. So what they do is when they receive this weekly ECRI alerts list, they go through the list and they perform a first pass to identify anything that might be related to a device that biomedical engineering would service. So they're essentially going through this list, performing a first pass, and they're trying to see and identify alerts that would affect electromedical equipment, lab equipment for certain health authorities, and so on. So following that, once they've performed that first pass, there's a weekly call that happens that PHSA supply chain leads, and that occurs on Friday mornings. And on that call, there's stakeholders from various different organizations within our healthcare system. So biomedical engineering attends that call, so that would either be Laura or Chris. But then there's all of these other centers of excellence that are on the call as well. So some examples of these would be facilities and maintenance operations, lab, medicine, ortho, ASI, and so on. And in the next slide, I'll show you some of those centers of excellence. So basically what happens during this call is PHSA supply chain runs through every single alert on that ECRI list, and it gets assigned to one or more centers of excellence. So what Laura and Chris will do is they've already performed the first pass of this list, so they have an idea of which alerts should be actioned to biomedical engineering because they affect electromedical devices. And during the call, they'll speak up, and whenever one of those alerts is mentioned, they'll say, yep, that's likely related to biomed. Please action that to biomedical engineering provincially, and then that alert would then be assigned to biomed. There are stakeholders from the other groups that would do the same. So somebody from ortho might pick up something that's related to, let's say, a hip replacement. They would speak up and say, yep, action that went to orthopedics. So then ultimately at the end of that call, that ECRI alerts list from the previous week has a center of excellence that's assigned for every single alert, and those centers of excellence are responsible for following up those alerts. And so here are all of the centers of excellence that attends that call. So as you can see, there's BC Cancer, Cardiac, FMO, and so on. That's ultimately what drives our Lower Mainland biomedical engineering alerts process, is that weekly alerts list that we receive or we've been actioned by PHSA supply chain to follow up. Okay, so that's the provincial alerts process. So I'm just going to pause the recording here and stop for any questions. Okay, so we're now recording again. The Lower Mainland alerts process, so this here is a flow sheet of the high-level steps involved with the process. You'll notice through the rest of the presentation that there's some flow sheets and they have numbers. So in this one here, you see the 5.3, 5.4. Those correspond to sections in the standard operating procedure. You don't need to worry about those for the purposes of this presentation. So our Lower Mainland alerts process starts with alerts intake. And so that's how new alerts enter our process, primarily, again, driven by that PHSA supply chain action item list. Following that, we have an alerts meeting. And so that's a new meeting that's started up, which involves representation from every single team across the Lower Mainland. And within that meeting, we discuss both new alerts as well as alerts that are tagged for follow-up during the week of the meeting. Following this, we determine actions related to an alert, implement those actions, and once those actions are complete, we close off the alert. And so Laura and I will be taking you guys through kind of a step-by-step for each of these high-level pieces of the process. So the first step here is alert intake. So this is a high-level overview of where our alerts come from. So the first method of intake would be receiving a vendor letter. So as a technologist or a supervisor, you might receive a vendor letter directly from the vendor or manufacturer, which indicates that there's been alerts published for the device. Proactive identification of alerts, so that involves any sort of alerts that we proactively identify. So we might see something, let's say, that Health Canada is distributed. We might read about something in the news even. We might see an alert published on a vendor or manufacturer's website, but we actually haven't received it directly from them yet. So that's more of our own going out and looking for alerts. And then lastly, where we receive most of our alerts is from that provincial process and that action item list that PHSA Supply Chain sends out once a month. And so when we intake an alert into our process, a record is created in an alert log, and I'll describe what that log is in a couple of slides. So once it's in the alert log, a TMS query is then performed. So any alerts that affects electromedical devices will enter the alert log. That doesn't necessarily mean that we actually service that device. So what the TMS query involves is looking through TMS to see if we actually have that device at any of our sites. So as an example, we might receive an action item from PHSA Supply Chain to follow up with an alert on a specific CT system. And so we will enter that alert into our alert log, and then the TMS query will be performed to see if we actually have that specific CT system anywhere in the Lower Mainland. And so we always create that record in the alert log, even if we don't service the asset, just to demonstrate that we have done our due diligence in making sure that that alert doesn't affect our organization or any of the organizations that we service. So if you as a supervisor or a technologist receives a vendor letter, what we would ask you to do is send that a letter to our alerts clerk. So that's bmeclerical@pch.ca. The alerts clerk role is primarily filled by Cheryl, but Emily and Ivy on the clerical team also are trained with accepting alerts into our process and creating records within TMS. Additionally, in terms of acknowledging receipt of the actual vendor letter, you can go ahead and do this. So most often when an alert is distributed, the vendor will want something signed to state that we have received it. So it's okay to do that, and then just let the alerts clerk know that you've done so. Again, in terms of the proactive identification, so everybody's more than welcome to monitor for new alerts from sources such as, let's say, FDA, Health Canada, ECRI, the Health Information Sharing and Analysis Center, that's more cybersecurity related alerts. And so again, if you see an alert out there and it's related to something that might affect your team, you think it might affect another team or affect a common model that's serviced, please do identify that alert and send it into the alerts clerk. Ultimately, we want to know about alerts, so the more sources of information we have, the better. The alerts clerk, Cheryl, has a process for ensuring if she's received the same alert from multiple different sources that it doesn't get a record created multiple times. And so the process is the same for if you receive a vendor letter directly or if you've proactively identified alert. Again, please send that in to Cheryl at the BME clerical address. And so the alerts meeting. The alerts meeting is something new that we've introduced to the process from when Laura started. And we found that that's been one of the biggest improvements and one of the biggest kind of drivers of change with the overall process. So the meeting is mandatory and it occurs on Tuesdays at 10:30 with the alerts group. And in the following slides, I'll touch on who the alerts group actually is. And so within these meetings, we review all new alerts. We assign coordinators for those alerts. And then we also receive updates on follow-up alerts that were tagged for follow-up during the week of the meeting. Typically, these meetings last about 15 to 30 minutes. In the pilot phase, when our group was a bit smaller, that was kind of the time range, and now that we've grown the group, and we have participation from all teams across the Lower Mainland, we're still seeing that it fits within that 15 to 30 minute time frame. So we try to keep them as efficient as possible because we recognize it's a lot to ask to have every single team on a weekly call. So in terms of the stakeholders and who's in the alerts group, and kind of what their high-level functions are. So there's the alerts chair. So the engineering group is currently chairing the alerts process. And so the responsibility of the engineering group is to direct the activities of the overall alert group, as well as to maintain the alert log records and oversee the process. The alerts clerk role is filled by a clerk, again, primarily Cheryl, and Cheryl supports with a lot of the alerts process documentation. An alert coordinator. So the alert coordinator role is a temporary assignment for a specific alert. This can really be anybody within biomed, so a director, manager, technologist, supervisor, engineer. And ultimately what an alert coordinator does is they will assess alerts, determine corrective actions, possibly complete reports, and they're ultimately responsible for following up an alert. And we'll dive a bit more into the alert coordinator role in a couple of slides. The last three stakeholders, so there's the alerts database administrator. So this is a member of the Lower Mainland Biomedical Engineering database team. So right now, primarily Laura or Tony. And so the function of the alerts database administrator is to perform that first pass of pending alerts. So those are alerts that have been identified and accepted into our process and require that TMS query to see if we actually service the device. So when the DBM performs this, when they perform the query, they'll look for both active and inactive assets within our database. And that's just to ensure that if we have an inactive asset that could possibly come back into service in the future, that alert's been actioned upon. And additional to this, they support all the TMS-related activities surrounding alerts. So in certain cases, they may help with risk management work order generation. They help with making the dashboards better and more usable for everyone. So everything surrounding TMS. Supervisors and technologists. So again, we have representation from every single team in the alerts meeting. And the role of supervisors and techs is to discover alerts, perform a second pass of pending alerts, and I'll talk a bit more about that in the upcoming slides, and then the response and coordination of alerts as well. And then lastly, we have the directors and other management staff, and that's to support their roles to support the processes required. Just a couple of definitions. So these are in here. These are 4 definitions of kind of key terminology for the overall process. So the first here is hazard reports, alerts, and recalls. And so we would consider these to be communications received by our organization that has identified a hazard related to medical device that may include specific information and actions related to our risk management. An alert log work order. So an alert log work order is a master tracking work order that is created for alerts that receive intake into our process. So within TMS, all alert log work orders are created in VCH's segment. And basically, they're work orders which track the alerts, but they don't have any time or action attached to them. So if an alert enters our process, it could or could not actually affect one of our devices. What the alert log work order allows us to do is it opens up a work order for anything, so it doesn't have to be an actual TMS asset, and it's where we track all of the activity and history surrounding that alert. The alert log is kind of the compilation of all of the alert log work orders. So the alert log is maintained within TMS, and it's located in VCH's segment. So when the database was set up, all of the alert log work orders had to reside in a place, and they couldn't reside in the common segment. So the alert log work orders for Fraser Health Authority, Providence Healthcare, Provincial Health Services Authority, as well as Vancouver Coastal Health, are all contained within Vancouver Coastal Health segment in TMS. Some of this probably seems a bit abstract, but in the next two slides, Laura's going to actually show you what this looks like in practice. And so lastly, risk management work orders are work orders in TMS that describe corrective actions in relation to an alert that affects one of our assets. So an alert log work order might be created for a device that we do service, for example, a ventilator. But that ventilator might not actually have a risk management work order created for it in relation to that alert if the alert was describing some sort of FYI action. So we only create risk management work orders if there's actual action that's required to be taken on a device. So I'm just going to pass it over to Laura here, and she's just going to show what the Alert Administrator dashboard looks like, as well as the alert log.
Thanks, Brendan, and give them a little bit of a break too while we're at it. So I have since redeveloped the alert log. So I'm just going to, show you, see the Alert Administration dashboard. It looks slightly different. I've reprogrammed it and cleaned it up quite a lot, and you'll see that from time to time when we're revisiting this process. So, but the important part is just how to navigate it. On the slide, you'll see that I have the YouTube, well, Brendan put that in, or my YouTube link there on how to navigate it, but just on the high level, you can see that we have the meeting pending and meeting follow-ups. So that'll be what you need to check before you go in for your meeting. I will stress that. You guys do that before you go to the meeting. We also have the alert log work order distribution. These are things like after the meeting, what you need to follow up on. And you'll see that there's assignments here to remind you who needs to do what. So if you want any more information on that, you probably want to go to the YouTube, but it's easy to navigate. Just make sure that when you log into your, I'm just going to show you, once you log into your TMS, you change it to the Alert Coordinator dashboard. That's the main point to that one. Okay, and then on to the next part of it. So sorry, I'm just going to move that over the way here. Next slide. Hello. The alert log querying, once again, I have a YouTube video to show you how to do that, but if you wanted to go and look at any previous work order alert logs, like Brendan was saying, these are non-actioned and actioned alert logs. So if you want to see them from the beginning of history itself, just make sure you put it in the VCH segment, and you can put an alert description, I don't know, Prisma, let's say, and you'll be able to query it and be able to see all the alert logs and what happened. So you can give yourself a read on that one. And that's the alert log process. So yes, you can query it just like a regular work order. The only thing is that you will want to switch the form to an alert log form in order to see what you're looking at. And then, oh yes, this is my favorite slide of them all. In order for this to maintain as a 15-minute to 30-minute meeting, I will highly stress that you do your homework. So make sure that you review the pending and follow-up actions. I also, before the meeting, I send an Excel sheet to tell you what the pending and follow-up worksheets are. So that's just more for a working side. I would recommend that you use the dashboard because it has all the attachments available at the fingertips. And you're going to review them and then identify if your team is affected. I always attach my Excel sheets when I do my first task. I will attach it to the alert log, so you can open the alert log, open the Excel sheet, and review to make sure that I've got all the assets, or if there's any that are missing. So the main point is to be prepared. And then, okay, so back to Brendan here.
Yeah, So now we're moving into what this meeting actually looks like. And so again, we review all new alerts that have entered the process from the following week. And then in addition to that, we look at the follow-ups. So this slide here shows what we do for the new alerts. So the first action is the alerts group will determine if an alert response is required. So an alert response will be required if the alert actually affects an asset that we service. So as Laura has mentioned, the DBM team will have already performed a first pass to see if we are affected, but sometimes they miss things. And that might be because they don't know exactly how the model is entered into TMS, what the nomenclature is. It might be that a specific device wasn't tagged and it wasn't entered in. And so what we do is we start with the alerts that have entered our process where we haven't found any devices that are affected, and then we will ask everybody on the line, so all the supervisors or their delegates, if they're aware of those devices within the hospital. And so we've actually seen quite a positive improvement with that extra step. In the pilot phase, we caught multiple alerts where the DBM team hadn't found anything in the database, but the healthcare institution that we service was actually affected. So we do that second pass. If following that second pass, none of the teams identify that they're affected or that they're aware of those devices being within any of our hospitals, we'll close off the alert log and that file will be considered done. If we determine that a response is required, so we are affected, an alert coordinator will be assigned. And so there's two types of alert coordinators that could be assigned, either a central coordinator or a supervisor coordinated alert. And so the vast majority of alerts are coordinated directly by the supervisors for their teams. But for some of the more complex alerts that might benefit from central coordination, that's where somebody centrally will review that alert. Ultimately, the alert log will be updated with whatever action is identified in the alerts meeting. So the actual assignment of coordinators. So supervisors coordinate alerts for their team when the general alert difficulty is low and the supervisor does not need further support from the central process. So something such as a software upgrade where maybe there's low patient risk would be considered to be something that the supervisor would coordinate directly. In terms of central coordinators, they would be assigned when the alert difficulty is relatively high, actions might be unclear, or if there would be benefit for supervisors in our teams from support from a central process. So this could include alerts with potential actions that would significantly disrupt patient care delivery, could incur significant financial cost in terms of parts and labors, and any sort of action that we'd really want to be consistent across all of our teams. An example, I guess, of a centrally coordinated alert would be the Alaris bezel alert that came out a few months ago. So with that alert, it affected multiple teams across multiple different sites, and there's quite a high degree of coordination and I would say project management going on in the background from a central coordinator. In this case, it's Emily from the engineering team, who's helping to support all of our teams handle this alert. So who could actually be a central coordinator? So really, again, this could be anyone across the lower mainland within biomed. We were just looking for people that would be knowledgeable in the clinical use of the device, knowledgeable in the design of the device, and have some experience with risk assessment. So if an alert is identified as needing a central coordinator, we'll ask for volunteers during that weekly call. And if you were to volunteer as a technologist or a supervisor or management staff, the engineering group will follow up with you offline and provide separate training on how to centrally coordinate an alert. So we won't go into that in detail today. And so assigning follow-up dates. So this has been another great improvement in terms of keeping tabs on open alerts. So any alerts that remain open following the risk management meeting will receive a follow-up date. And what these follow-up dates is, what they do is they help us ensure that alerts won't slip through the cracks. So previously there might be some action surrounding an alert, but there was no kind of flag to follow that up later on. So what these follow-up dates do is Laura's created a special dashboard that will pull up any alerts that have a follow-up date scheduled during that specific week, and that dashboard will pull all of those forwards. So we maintain kind of constant eyes on open or in progress alerts. And so how do we actually assign a follow-up date? Right now, we're just using the best knowledge available at the time. As an example, if it's an alert where we're waiting for vendor action, and that vendor has said, there's a software update required, it's still in development, we think it's going to be available in, let's say, November, we would set the follow-up date for November, and that would bring it forward again during that week. We would look at our notes from the history, and we would see, the vendor said that they would have a software update prepared at this time, and then we would follow up with the vendor. As the process does evolve, we are hoping that the information and data that we receive will help us better predict what a reasonable follow-up date might be based on a risk assessment of the specific alerts. So the second piece in terms of the meeting is surrounding the follow-up alerts. And so follow-up alerts are, again, any alert that were scheduled for follow-up during the week of their alerts meeting. And so if these are brought forwards, what we do is we run through all of them and we identify which teams were affected, and then we'll ask for an update on that alert. So basically what we're trying to determine is there further action required? If no, that means that alert must be complete. Everyone's risk management work orders and the action has been performed, and we'll close off the alert log. If further action is required, so if all of the actions aren't complete, we would then schedule a new follow-up date and update our alert log, which contains kind of the master record on the alert appropriately. And so Laura and I, at the end of this presentation, are going to just do a demonstration meeting so you guys can kind of see what it looks like. And I guess what I would also say is a lot of the TMS-related stuff is probably quite new, and it's probably still a little bit abstract. I know it took me at least a little bit to pick up on it, but I think as you become more involved with the alerts process and start actually seeing some of these dashboards, seeing what the alert log looks like, getting in there, it is fairly intuitive. And so I think this would be a good place to stop again for a break. So I'm just going to pause here. Okay, so we've resumed. So determining actions related to an alert. So for determination of actions, we haven't introduced any formality around this yet, but we do have a suggested structure in terms of the thought process, which we're hoping everyone can use when they're thinking through an alert. And so this begins with a risk assessment. So what's our organization's assessment of the risk described within the alert? And so when we're looking at alerts, we try to think of what's the probability of the hazard described in that alert actually causing harm to the patient or the operator. And then in addition to that, what's the potential severity of the harm that's occurred? So if it's something that's low probability of happening and has a low probability of harm to the patient or operator, that would be something that's probably relatively low risk, and we wouldn't consider as critical. But if something has a high probability of occurring and a high potential for harm, obviously there's a higher risk associated with that. Containment. So containment concerns any sort of immediate action that might be required. So this would be quite rare. This would include anything that might warrant an immediate response. So something where, let's say, there's an alert that comes out on the ventilator, we read it and we think, okay, those ventilators are not safe for use for patient care. We need to go out, inform clinical staff, and come up with a plan to get them off the floor. So we weren't able to actually come up with any examples from recent history where containment was required for an alert. Investigation, so that would include the results of any further investigation that might be involved with looking at an alert. So things where there might be, local consideration. Perhaps the alert is describing something that's clinical practice related, and you do some extra investigation to see if that sort of practice is actually being followed within the healthcare organization that you service. And so within that further investigation piece, you'd want to document that. And then lastly, the action. So action should be very clear, very concise, brief, and only describe exactly what needs to be done in relation to an alert. So implementing an action. So if an action is required to be taken on the actual device, such as a software upgrade, a hardware upgrade, relabeling, that would require a risk management work order to be generated. So risk management work orders are created in relation to alerts, and they describe the actions that need to be taken. So often supervisors will choose to delegate the risk management work orders to their technologists on their team to execute. And so historically, risk management work orders have been generated from the central alert coordinator on the DBM team, and then they were pushed out to all the different teams. But there was quite a bit of negative feedback around that with risk management work orders that weren't necessarily clear to follow, didn't have a lot of context. And so we've tried to improve that. And as part of that, Laura's created the ability for supervisors and technologists to generate their own risk management work orders. And so if a small number of assets are affected by an alert, we will ask during the weekly call that those risk management work orders that need to be generated are generated by the supervisor or by the supervisor's delegate. And so Laura's created a YouTube video for both creating risk management work orders as well as duplicating them. And so she's also, in addition to that YouTube video, providing weekly sessions right now where she shows how to actually create the work orders. If there's a large number of assets affected, either the alerts database administrator or Cheryl, our alerts clerk, can help with the generation of the risk management work orders. So as an example, with the Alaris Bezel alert, it would be completely unreasonable to ask our teams to generate all the risk management work orders for the thousands of assets that are affected. So that's being done centrally on behalf of the teams. So ultimately, in terms of implementing actions related to an alert, supervisors are responsible for controlling the completion of those risk management work orders. So again, they might assign those risk management work orders to technologists. They will notify techs that risk management work orders have been assigned. They will ensure that technologists have updated the risk management work order completion comments, including any issues faced with completing the work, and then also monitoring risk management work order progress and ensuring risk management work orders are completed as planned. And so I guess one comment on the completion comments in risk management work orders. Centrally, we do look at those. So that's how we kind of follow along to make sure that the alerts are progressing as planned. And if there's challenges that are described in the completion comments with performing a certain risk management work order, that's where centrally we can look at trying to provide some support. But we can only provide support if we know about it. So the documentation piece is quite important.
There's one more piece I was going to add, is that for techs and supervisors who are generating risk management work orders, they need to attend this, they need to be able to do the risk management work orders appropriately, in which case they do need training for it. You guys have been allocated as to do risk management work orders. If you have any delegates, they will need to go through this training as well, because the documentation is so critical in this type of work. All right.
And so responding to alerts outside of the alerts meeting. So one of the big pieces of feedback that we received on the previous alerts process was that it was slow. So teams wouldn't receive risk management work orders related to alerts until weeks, sometimes months after the alert had actually been published. So with our new process, we're still a little bit behind because we're relying on that weekly ECRI alerts list to identify the vast majority of alerts that we action upon. But we did want to address that feedback on kind of the slowness. And so what we've done is we've created the ability for alerts to be responded to outside of that alerts meeting where the alerts are formally assigned. So this corresponds to or would involve relatively simple alerts. So again, something where there isn't a high risk of patient harm and the action's relatively clear and straightforward. So as an example, again, something such as a software upgrade. And so if you identify an alert and you want to respond to it immediately, these are the steps that we would ask you to take. So the first step would be to send the alerts, the vendor, the manufacturer letter to the alerts clerk, same as usual, so that's to Cheryl. And then 2, you would go forward and create the risk management work orders for that alert, and you would describe the action that you're taking. Within risk management work orders, there's a field for the alert log number, and that field is what attaches that risk management work order to the master alert log. And so in this case, because the alert log hasn't already been created by Cheryl, so you've only just sent her that vendor or manufacturer letter, you can just put a 1 in as a placeholder into that field. So in the background, once Cheryl does receive that letter, she will generate the alert log, and that alert log will have that alert log number, which she will then follow up with you. So she will send you back the alert log number, and it then needs to be input into the risk management work orders. And then lastly, during the weekly alerts meeting, anybody that's already responded to an alert just needs to let the alerts chair know that they've already responded. And so again, I think some of this is probably abstract, and understanding exactly what these numbers mean, such as the alert log number and how that actually attaches to the alert log. I think that will become more clear as you become more involved in the process. So ultimately, once an alert response is complete, the alerts chair, and again that's the engineering group, will update the alert log to state that the alert response is closed, and then we will close it off, and that alert is considered to be complete. And so we just have a slide here, and Laura's going to just show you quickly what an alert log, what a risk management work order looks like.
Yeah, and once again, Tuesdays, I'll be doing a tutorial, so I'm not going to go too in detail about this. I've got lots of paperwork that you guys can look at, and YouTubes and references, but really just the general layout of things. So the way that a risk management work order is designed is that, like Brendan was saying, is that it needs to be able to track back to the master alert log. Our alert log is our center of knowledge, and so these work orders are going to be kind of like the child to the parent work order. So on this side, on the left-hand side, you'll see all the alert log information on the left hand, and on the right-hand side is just your ECN number that you'll be putting in, and this all gets populated for you. So we'll make one risk management work order per asset, and the reason being is going back to our original discussion about alerts, is that supervisors were having difficulties tracking with multi-asset work orders, especially large ones. A good case was the Alaris pumps, where you would be waiting for 4 Alaris pumps and could not close a work order until those 4 Alaris pumps were found. So it is easier for us to track individually, and we've noticed a great success and improvement based on doing one work order per asset, even though the paperwork seems a little bit high. It's not that difficult once you learn how to duplicate it. So left, alert log, right, is going to be your asset information, and then your requester details will be your notes that you can transcribe to your text to let them know what your expectation is for getting the work order completed. So that's my high-level explanation of the work order.
Okay. So I'm just going to pause here again. So I just paused the recording. Okay, so the recording's resumed. So now we'll just go through a very short demonstration of what the weekly alerts meeting looks like. Laura's going to be playing multiple roles. Yeah. We will start here with this alert. So this is an alert on the Emotion Fitness Motion Cycle 600 ergometers. I believe these are kind of like pedal bikes. So the DBM team has done an initial asset search for this alert, and they haven't identified these devices at any of our sites in the Lower Mainland. We just wanted to double check, is anybody aware of these ergometers at any hospitals that we service? Okay, I didn't hear anything, so we will assume that there are no sites affected by this alert, and we will close it off. Moving to the next one here. So this one is for the Medtronic Closure RF radio frequency generator. And so we've done an initial search, and the DBM team identified 2 units at Providence Healthcare, but they also identified that we were not affected because this alert only impacted certain serial numbers, and those serial numbers were not within the actual models that we have at Providence. And is anybody on the line aware of these RF generators at any sites other than PHC?
Brendan, it's Charmaine from Landscape. I think we might have one of those old ones kicking around in Bella Coola, so I'll need to get in touch with the clinical to see. Do you mind if I follow up with you later?
Yes, of course. Roughly how long do you think that will take?
Well, she's supposed to be back next week. I think she's away this week. So let's make it for next week or the following week. How about 2 weeks from here? I have to get in touch with her.
Sounds good. So maybe we'll assign a follow-up date for October 1st?
That sounds good.
Awesome. Great. I'll save that. Perfect. Alrighty. Next one. Okay, this next alert affects the BD LRS pump modules, specifically the 8100 large pumping module. And so the description of this alert was that 6 plastic posts that are critical for the accurate delivery of infusions and fluids have a premature susceptibility to cracking, which can ultimately result in overinfusion or underinfusion. So the database team has performed an initial look through our database, and we are affected across the board. So pretty much every single site across the Lower Mainland has these pumps and is affected. This alert looks to be fairly complex in terms of there's an actual hardware fix that's required. There's various different risk classifications and communications required with every single impacted site. So I think this one might benefit from a central coordinator. Is there anybody on the line that would be willing to coordinate this one on behalf of the Lower Mainland?
Hi, Brendan. It's Emily. I actually got in touch with the vendor already. We're BD and I are talking about where our potential machines are affected, and so they're supposed to be getting back to me regarding the buckets of which ones are going to be affected and what priority. So I'm hoping to get back to you next week on that. So yeah, I can quarterback this one.
Okay, awesome. And so would it be reasonable for you to provide the alert group with an update for next week?
I'm hoping so, yes.
Okay, so let's assign the 24th, and we'll save that, and we will touch base with you next week. Thank you. Okay, next one, only 2 left. So this one here is for the Natus Neo Blue Blanket LED Phototherapy System. And so the problem description for this alert was that the fiber optic bundle at the pad can melt or degrade due to excessive heat. And so we've looked at this one centrally and done a quick review, and it looks like the risk to patients is relatively low. The suggested action is to exchange the entire phototherapy system with a newly designed one. So we think that this one can be coordinated directly by the teams. And so the DBM team has done an initial asset search, and they found these devices both at Surrey and Burnaby. First off, is there anybody on the line who is aware of these devices in one of their sites, but they haven't been identified as being impacted? Okay, I don't hear anybody, so I'm assuming it's just Surrey and Burnaby. So Kim and Laura, would you be able to generate risk management work orders for your impacted devices with the recommended action that these systems are replaced?
Yep, no problem.
Awesome. If you have any issues with that, you can follow up with Laura, and she can help walk you through it. And so it looks like there's going to be a bit of a delay in terms of actually getting the new systems on site. So we'll sign a follow-up date from a month from now, and we'll check in to see how things are going.
Sounds good.
Thanks. Okay, last one. So this last alert is for the Medtronic 2090 CareLink 29901 Encore programmers for the transcatheter pacing system. And so this specific alert corresponds to how the programming software calculates the longevity values for how much time is left with the battery and the pacemaker. So again, we've looked at this one centrally. The recommended action is to apply a software fix. There seems to be relatively low patient risk in terms of potential for harm and the probability of this hazard actually occurring, resulting in harm. So again, we think this one can be coordinated by supervisors directly. So the DBM team has done an initial search, and they've identified Burnaby, RCH, St. Paul's, the Falcon team, Lionsgate, UBC, and the White team. Are there any teams that are aware of these systems at their sites that haven't been identified on this list? Okay, I will take that as a no. And so then can the supervisors from all these teams please generate risk management work orders for their assets that are impacted? And again, the suggested action is just a software fix.
Brendan, it's Courtney from St. Paul's. I just wanted to let you know that I did receive the software already, so I'm not too sure if any other supervisors got it, but if they need to get in touch with me, I do have software that I can send off after I'm done with our devices.
Amazing. Thanks, Courtney. So yeah, if anybody, any of the supervisors that are impacted needs the software, hasn't received it yet, please just reach out to Courtney and she can send that off to everyone. And yeah, so maybe we'll sign a follow-up date for 3 weeks from now. Does that seem reasonable?
Yep.
Okay.
They're pretty easy to do. It's just hunting them down.
Gotcha. Alrighty. Oops. Okay, so we will follow up with everyone 3 weeks from now. So that's all of our pending alerts, so the new alerts that have come in from the previous week. So we'll now move to the follow-up alerts. And so this week it's a very short list. We only have one. And so we're now pretending like it's the week after, and we're asking for an alert on the Alaris bezel alert. So Emily, last week you took this alert away. You were going to do some background digging into the bezel alert. Can you provide us with an update on what you found?
Yeah, sure. So BD got in touch with me. We had a lot of discussions, and apparently they have had high priority and mid priority. They're both very likely that they'll have this sort of break. They've identified which sites that are going to be at the highest risk, and unfortunately it's Surrey Memorial that's going to be hit first. So I might have to start coordinating with the sites to see when we can get remediation started. BD is going to get back to me on when they want when they'll have availability to start the remediation.
Okay, so it sounds like you got things under control. Maybe it would be beneficial to send out a communication to all of the supervisors that are impacted, just so they kind of know where they sit in terms of the remediation schedule.
Yep.
And so maybe it would be helpful, just because of the extent of this alert, to provide another update next week.
That'd be great.
If there's anything. Okay.
Yeah.
All right. Thanks. So I'll sign a follow-up date for next week. Save that, and we'll touch base with you again. Awesome, and that's all the follow-ups we had for this week. So that concludes the meeting. Was there anything else anybody wanted to bring forwards? I'll take that as a no. Thanks to everyone for joining today.
Thanks, Brandon.
Okay. So that's basically what the weekly risk management weekly meeting looks like. And so, typically we would say, let's say, have maybe, I don't know, 10 to 15 pending alerts, with the vast majority not affecting any assets that we service. And then for the follow-ups, it really depends on the week. We do try to clear off kind of the easy wins before the meeting in order to keep everything moving as quickly as possible. But yeah, so the meeting typically lasts about 15 to 30 minutes, depending on the alerts that are being discussed. And so that concludes the session and all the training that we had for today. So I'm just going to stop the recording.